Hey everyone, and welcome. Today, we're going to pull back the curtain on artificial intelligence. We're not here to talk about the hype, though. We're going to explore the structured, step-by-step journey that takes an AI model from just an idea to a powerful tool you can use in the real world. So, let's dive in.
You see AI everywhere, right? It's in your phone's camera, it's used in complex financial models. But how does that actually happen? How does a simple concept get turned into a tool that can predict, classify, and even learn on its own? Well, it's not magic, I can tell you that. It's a process.
And that process, well, it has a name, the machine learning lifecycle. The best way to think of it is as the official blueprint. It's the set of plans that engineers and data scientists follow to build AI that's reliable, accurate, and can scale up. So here's our game plan for today. We'll start with the what, then we're going to walk through the 4 key phases of the journey. We'll start with laying the foundation, then preparing our data, then building the actual model, and finally deploying it into the real world. And we'll wrap it all up by talking about why this whole process is so incredibly important.
All right, let's start at the very beginning with phase 1. This is all about laying a rock-solid foundation. You wouldn't build a house without a blueprint and quality materials, right? It's the exact same idea here. You can't build a good AI model without a super clear goal and really good data.
And this phase really boils down to 2 essential first steps. First, you have to clearly define the problem you're actually trying to solve. And second, you've got to gather the data you're gonna need to solve it. Problem definition is literally the blueprint for your entire project. This is where you're in the room with all the stakeholders asking those crucial questions. What business problem are we really trying to solve here? And what does a win actually look like? Getting this right from the start is so important because it stops you from building a totally brilliant solution to the wrong problem. Okay, blueprint's done. Next up, we gather our raw materials, the data. But listen, it is not just about getting a ton of data, it's about getting the right data. You have to ask, is this data even relevant to our problem? Is it accurate? Is it ethically sourced? And do we have enough variety in our data to actually reflect the complexities of the real world? So let's move on to phase 2. We've got our raw materials, but just like in any construction project, you can't just use them as is. They need to be shaped, cleaned, and refined before you can even think about building. This is the data preparation phase. This involves 3 key things. First, we clean the data to fix all the errors and inconsistencies. Second, we explore it to find hidden patterns. And third, we do something called feature engineering, which is this really cool kind of creative process of picking and transforming the data variables to help our model learn way more effectively. And you pretty much never use raw data as it is. Real-world data is frankly a mess. It's usually full of missing values, typos, all sorts of errors. Just throwing that chaos into a model is a guaranteed recipe for failure.
This shows the transformation perfectly. You take that chaotic, messy, raw data on the left, and through all that cleaning and pre-processing, you turn it into something consistent, organized, and totally ready for a model to actually learn from. Okay, once the data is squeaky clean, we do something called exploratory data analysis, or EDA for short. Think of this as being a detective. You're using statistical tools and charts to really get to know your data. You're looking for patterns, for trends, for anything that might guide you when you start building the model. All right, with our foundation laid and our materials prepped, we are ready for the main event, phase 3, building the actual model. This is where the magic really starts to happen. This whole phase is kind of like a 3-step dance. First, we select the right type of model for our specific problem. Then, we train it on our beautiful, clean data. And finally, we test it, evaluate its performance, and then tune it to make it even better. Selecting a model is just like a craftsman choosing the right tool for the job. You wouldn't use a sledgehammer to drive a tiny nail. In the same way, you choose an algorithm based on your specific problem. Is it simple or complex? How fast does it need to be? It's all about finding the perfect fit. Now, model training is where the real learning happens. We feed our clean data into the model we chose, and it goes through this iterative process. It makes a prediction, checks how wrong it was, adjusts itself, and then tries again, over and over and over, getting a little smarter each time. So how do we know if it actually learned well? We test it. We use key metrics like these. Accuracy is the easy one. How often is it right? But sometimes that's not the whole story. For example, in medical screening, recall is vital. We want to find all the positive cases, even if we get a few false alarms. Precision, on the other hand, measures how many of the positive predictions we made were actually correct. It's all about finding the right balance for your specific needs.
Okay, we have a trained and tested model that's performing great. We're done, right? Well, not quite. Phase 4 is all about putting our amazing model to work in the real world, and crucially, making sure it stays effective.
And this final phase has two big parts. First, deploying the model so people and systems can actually use it. And second, continuously monitoring it to make sure it keeps performing the way it's supposed to.
So, picture this. The model is built, it's tested, is performing brilliantly on a data scientist's laptop. Now what? What do we do with it? We deploy it. This is where the rubber meets the road. We integrate it into existing websites, apps, or business systems, maybe through an API, so it can start making real-time predictions. This is the step that actually delivers the value we were aiming for from the very beginning. But, and this is so important, the journey does not end when you go live. A model out in the wild is like a living thing. It needs to be watched and cared for constantly. And that's where monitoring and maintenance come in. We track its performance to catch any dips in accuracy. We look for something called data drift, which is just a fancy way of saying that the world changes, and the new data the model sees looks different from the data it was trained on. And when that happens, the model needs to be retrained to stay relevant and accurate. So we have walked through the entire life cycle, from A to Z. But why all the fuss? Why go through all this trouble? Why is this structured process so darn important? I mean, we've seen the whole journey, right? We started with the foundation, moved to preparation, then the actual building, and finally deployment and beyond. Ultimately, it's about this. This life cycle is what turns machine learning from a kind of experimental academic exercise into a reliable, predictable engineering discipline. It's what ensures that the models we build actually solve real problems, give us true insights, and can be trusted to work at scale for a long, long time. And that leaves us with a really fascinating thought to chew on. If a model's work is never really done, if it has to constantly adapt to a changing world just to stay accurate, can we ever say an AI model is truly a finished product? Something to think about.